this is one of the very important modules because you have almost all important questions coming from this module. We have linear programming formulation, then we have graphical method, then we have simplex method, and finally we have problems on degeneracy. Okay, these are the 4 different sections what we have in this chapter. And usually even in the exams also, the case study questions will usually appear from this module. Okay, so it could be either Modi method or it can be a simplex method problem for 15 marks, or definitely 10 marks question can be expected here. That's exactly how usually in the examinations this chapter was figured. And not just only from the operation research or this semester point of view, even for the students who are planning to take up finance as the specialization in the next semester, I think we are going to use the concept of linear programming problem in many occasions. Okay, so you have to learn this module only not from the second semester point of view, but even for your coming semesters, these concepts are very much used. This is one chapter where the financial applications are found, and the next chapter where majority of the financial concept is based is on project management. I think the network analysis chapter what we have covered, so it is by and large used in project management in your finance specialization. There also the application of this model is very widely appreciated. Okay, yeah. So that is the importance of this module. So let me start with this module with a brief introduction, and then maybe from next class we'll start with the problems. Okay, yeah. To start with, you're able to see the board, everyone?
Yes, sir.
Yeah. Okay. As per the syllabus, actually this particular chapter comes in 3rd module, but because of the convenience and the comfort, we thought we'll start this module at the end. But anyway, this is actually in serial as per the order of the syllabus. It is in module 3. Okay. So linear programming problem is what this particular chapter is called as. Well, if you look at this particular heading or the chapter name, linear programming problem, you can actually see this is a combination of 3 different words: linear, programming, and problem. Okay, let's try to understand what exactly each of these words signify. Okay, the first is linearity. I hope again the word linear is something which is very commonly used in most of the subjects. I think in economics we have used the word linear many a times, and even in marketing and many other general conversation we use the word linearity. Can anybody please define what is the English meaning of the word linearity? Then we'll come back to the mathematical definition. Okay. Normally we use the word linear relationship or linearity. What exactly we mean by the word linear? Can I get some answers from the class? How do we define the word linear, or what is linearity?
Sir, one-sided, sir, like straight.
Straight. Okay. Very good. Yeah. Any other way of defining the word linearity?
The in line or a single line kind of thing.
Okay, in line with, or something which synchronizes, something which syncs, something which goes hand in hand, something which is exactly correlatable, something which lies within a stipulated boundary. I think these are the various ways of defining the word linearity. Usually the linearity or linear relationship is observed when there is not much of discrimination between 2 variables. Say for example, we say the percentage and the marks scored are linear. That means whenever the marks scored increases, the percentage also goes up. Or whenever the marks scores come down, the percentage also come down. So we say there is a linearity. Similarly, we talk about demand and price. Whenever the demand increases, the price also considerably goes up. When the demand falls, the price also falls. So similarly, there are humpty number of examples that we can relate where the relationship or linearity relationship can be seen. So this is the general way of defining the word linear. But mathematically, how do we define linear? Of course, mathematically or general English, the meaning or the way we define is more or less same. But in mathematical definition, we try to define the word linearity or linear with the help of equation. An equation is used. Generally, the linear equation is defined as f of x is equals to ax plus b. So any equation of the form ax plus b can be called as a linear relation. Okay. If you look at this particular equation clearly, you can see that x is a variable and a and b are the constants. That means in any equation, an equation is always a combination of variables and constants. Okay. So you can see a and b are the pure constant and x is a variable. Now, what is the meaning of variable? Anything which can vary or anything which can assume different values, we call it as variable. So the value of x can be changed. We can give any values to x, and accordingly, the entire equation value also changes. If I'm giving the value of x equal to 0, and of course, if a and b are constant, let's say I put it in a mathematical form like 5x plus 6. If this is a linear equation, depending on the value of x, the overall value of this particular equation keeps changing. If I'm putting x equal to 0, then the final value of this equation becomes 6. If I'm putting x equals to 1, then it will become 11. If I'm putting x equals to 2, then it becomes 16 and so on. So depending on the value of x, the overall meaning or overall value of the equations also keeps changing. That is basically what the function or the advantage of the variable. That is one part of the story. But what is that we are supposed to understand from this equation? That is more important here. I'll be writing certain equations here. I want you to please tell me how exactly each equations differ from the previous one. The first equation is of course ax plus b. We call it a linear equation. The second equation is ax square plus bx plus c. Third equation is ax cube plus bx square plus cx plus d. And fourth equation is ax to the power of 4 bx cube plus cx square plus dx plus e and so on. If you look at all these equations, each equation has got certain important points to understand. Can anybody please tell me what is the difference that you notice in each of these equations? Hello? Can anybody please tell me what is the difference that you can make out in each of the equations in terms of its structure?
So after each, like after ax plus b, there is an increase in one variable, and there is a cube or a square on it. So it becomes a quadratic equation or a other kind of equations.
So correct, you are absolutely right. If you look at the first equation, what I'm trying to understand here is, or rather I would like you to understand here is, if the degree of the variable happens to be 1, then the number of constants is 2. I want everyone to please relate my words to the equation here. If you look at the first equation, I'm saying the linear equation as ax plus b, where x is the variable and a and b are the constant. Now, if you look at the degree of x, what do you mean by degree? The power. If there is nothing, obviously it means x to the power of 1. That means if the degree of the variable is 1, then the number of constants is 2. If you go to the second equation, this is called as quadratic equation. If the highest degree of x is 2, then you can see the number of constant is 3. Then we come to the third equation, it is called as cubic equation. Whenever the highest degree of the x happens to be 3, then the number of constant becomes 4. Then we have the fourth type of equation, it is called as biquadratic equation. Here if the variable degree happens to be 4, then the number of constant is 5. So what is the general understanding that we can get from all the equation? Whenever the degree of a variable happens to be n, then the number of constant will become n plus 1. It will be always 1 more than the highest degree. So this is what the schematic representation we get from this group of equations. But as far as our understanding or our syllabus or maybe the linear programming is concerned, we are only dealing with the first type of equation, where the number of constants are limited to 2 and the highest degree of the equation happens to be 1. We are not worrying too much about the quadratic, biquadratic or cubic equations here, because there are different mechanisms to treat them. We have something called as goal programming, we have sensitivity analysis, dynamic programming. So I think these are the other extensions of linear programming problem where we are going to deal with the other type of equations. Okay, so by and large, as far as linear programming problem is concerned, linearity refers to, here we are trying to take or consider those set of variables which has a perfect synchronization between them. ಅಂದ್ರೆ ಯಾವುದೇ ಒಂದು ವೇರಿಯೇಬಲ್ ನಾವು ಕನ್ಸಿಡರ್ ಮಾಡಬೇಕಾದ್ರೆ when it comes to formulating a linear programming problem, the basic requirement here is there has to be always a relationship established. ಒಂದು relationship establish ಆಗಿರಬೇಕು. You cannot take two strange entities and then try to study linearity there. It doesn't happen that way. There has to be a relationship exist between the variable. With that existing relationship, we can possibly build further. That is one thing. That is the first word or linearity we are talking about. Second one is the programming. I think again the word program is something which is very commonly used in computer or IT related activity. Simple words ಅಲ್ಲಿ programming na define ಮಾಡಬೇಕಂದ್ರೆ you would say it's a set of instructions, right? A set of instructions that is given to the computer to perform a particular task can be called as programming. Of course, the way you give the task or the way you give the commands and instructions, it varies depending upon the complexity of the task you're giving. A simple problem, I think the programming coding would be very minimal. In case if you are trying to give or write a program for a very complex situation or a complex task, then obviously the coding and the programming also becomes more complex. So generally, programming here refers to a set of instructions. Here, what are the set of instructions we are giving here? See, whenever you are trying to formulate a linear programming problem, or when you are trying to create a LPP model, it is very important for a researcher to clearly manifest the algorithm. Again, algorithm is nothing but a step of instructions. What is done after what? So, a purti sequence na series na define madidre, that basically comes under the programming part, the instructions part rather. And finally, the last word, it is called as program. So what is program here? A program is nothing but representing all your functions in a mathematical form. And then you are trying to give a status of numerical problem to that. Because only when you are able to represent all your qualitative statements in the form of equations, then the equations can be solved. Now, very numeric, verbal agi kellu sentence na ನಾವು solve ಮಾಡ್ಲಿಕ್ಕೆ ಬರಲ್ಲ. You cannot solve a sentence. It has to be expressed in the form of mathematical equations. Only when the mathematical equations are ready, or only once you are able to draft a mathematical equation or come up with a mathematical equation, the solutions become possible. Okay, so totally linear programming problem is a mathematical approach of solving certain set of equations. Okay, Iga we'll try to understand what is the application of linear programming problem in management. Why is that in management we are more concerned about linear programming problem? Okay. Let me explain in a very simple way. Well, if you look at the origin or the history of linear programming problem, it all started during World War II. I think the entire concept of operation research was developed during World War II. In fact, before it was considered as military operation research. I think I was mentioning about this during my introductory classes. Okay, the word operation research is actually derived from military operation research, because the concept of operation research was first started in military. The US Army or the US defense system wanted to come out with a mechanism where they're able to deploy all their military resources very profitably, so that with minimum casualty they're able to do well in the war. Adu avara ಒಂದು objective ಆಗಿತ್ತು, right? Because the resources were always limited. ಯಾಕೆ ನಾವು ಆಪರೇಷನ್ ರಿಸರ್ಚ್ ತುಂಬಾ ಇಂಪಾರ್ಟೆಂಟ್ ಅಂತ ತಗೋತೀವಿ ಅಂದ್ರೆ, whenever the resources are limited, when there is absolutely no scope for enhancing the resources, then the only possibility before you is optimize the resources. ಇದು ತುಂಬಾ ಇಂಪಾರ್ಟೆಂಟ್. ನಾವು ರಿಸೋರ್ಸ್ ನ ಜಾಸ್ತಿ ಮಾಡ್ಲಿಕ್ಕೆ ಆಗಲ್ಲ ಅಂದ್ರೆ, the only option left before an individual or the company will be optimizing the resources. And then you have to go to the limits. You should see what is the maximum I can stretch with the available resources. If you are able to deploy, if you are able to come out with more mechanism, if you are able to enhance the productivity, they all come under the ambit of optimizing. So the military of US also wanted to optimize the resources, because they cannot increase the resources overnight. ಇವತ್ತು ನನ್ನ ಹತ್ರ 1,000 people, 1,000 soldiers idare andre, but next morning I cannot make it 2,000. I can't do it. The only way what I can do is I should be able to come out with a strategy how effectively I can use this 1,000 people so that I can really combat the war. I can really have an edge over my enemy. That's exactly how this principle of operation research came. So linear programming problem is the most fundamental concept of operation research, where the primary objective LPP is allocation of resources. ನಮ್ಮ ಹತ್ರ ರಿಸೋರ್ಸ್ ಇದೆ, ಅದನ್ನ ಎಷ್ಟು ಪ್ರಾಫಿಟಬಲ್ ಆಗಿ ಅಲೋಕೇಟ್ ಮಾಡ್ತೀವಿ. If that is the objective of your company, I think the best tool that a company can use is linear programming problem. So linear programming problem ಯಾಕೆ ನಾವು ಯೂಸ್ ಮಾಡ್ತೀವಿ ಅಂದ್ರೆ, this is a tool which helps the organization to decide an ideal way of allocating the resources. Now the question is, when we talk about resources, is it always a resource refers to military resource? No, not necessary. Because initially, of course, the concept was used abundantly or predominantly by military, but later on in the early 60s and 70s, many organizations started realizing that if military can deploy its resources very profitably using LPP model, why not the same principle can be used in our industry also? That was the time when the operation research word was coined. Initially military operation research ಅಂತ ಏನಿತ್ತು ಅದನ್ನ ಚೇಂಜ್ ಮಾಡಿ it was called as operation research, because the industries and academicians started realizing that the scope of military operation research can be extended to other fields also. Now the operation research or LPP model is so much vibrant that there is no field today where operation research is not used. Starting from pharmacy, military, agriculture, economics, you name any field of knowledge today, invariably the concept of LPP used, because it's a most fundamental principle of any organization. Because unless and otherwise you have optimization techniques in place, you will never be able to claim that you are a better industry. At least now during this COVID-19 pandemic, everywhere, every industry is just trying to explore the possibility for optimizing the resources. ಯಾಕಂದ್ರೆ ಇವಾಗ ನಾವು ಹೊಸ ರಿಸೋರ್ಸಸ್ ನ ಕ್ರಿಯೇಟ್ ಮಾಡಕ್ಕಾಗಲ್ಲ. We are not able to create resources as and when we require, because it has got its own limitations, right? So whenever it is not possible to create resources, the best way to deal with that is optimize the resource. You can take the examples of HR, marketing, production, finance, supply chain management, analytics. I think all functional areas of management where LPP models are used. I think already we have seen the application of OR and LPP in marketing. I think in finance, financially, for example, risk management. I think the very concept of risk management is a result of operation research, right? Again, if you talk about marketing, I think we have solved problems from traveling salesman problem or assignment. I think that's a classic example where we are able to identify the best possible route which your representatives or your team people can take up to reach more customers in limited time. Of course, when you talk about production department, I think we have replacement problems in sequencing. The ideal examples where the companies are applying the operation research by and large. Similarly, we also learned the concepts of network analysis. I think the project management, which right away applied in all industries when it comes to project management. Of course, the finance students are going to study this separately as a project management subject, where we are going to understand all the intricacies involved as far as project management is concerned, right? So I think all these examples very clearly demonstrates that whenever there is a question of optimal utilization of resources, invariably the linear programming problem and the other concepts of operation research comes into picture. Okay, now I think you have got a fair idea about what is linear programming problem and why exactly the linear programming problem is used. But when we talk about the structure of linear programming problem, and what exactly we are supposed to do in linear programming problem, right? All linear programming problem basically has 4 important levels. Andre ತುಂಬಾ ಸಿಂಪಲ್ ಆಗಿ ನೀವು ಅರ್ಥ ಮಾಡ್ಕೊಳ್ಳಿ. A statement problem is given to you and that statement problem has to be converted into mathematical equations. ಅಷ್ಟೇ. If you blindly want to understand what is linear programming problem, it's a process of converting a set of sentences into equations. ಒಂದು ಕೇಸ್ ಇರುತ್ತೆ, ಒಂದು ಕೇಸ್ಲೆಟ್ ಇರುತ್ತೆ, ಅದನ್ನ equations ಆಗಿ convert ಮಾಡಬೇಕು. So in order to convert into equations, there are certain steps followed, and those steps are called as components of linear programming problem. And whenever you are formulating a linear programming problem, it is mandatory that every linear programming problem shall have 4 important components. So what are the 4 important components? Let me write that. And please remember, this is the most important part in this entire chapter. So whenever you are formulating a linear programming problem, we are trying to convert the statement problem into these 4 steps. The first important component is called as decision variable. Okay, the first one is called as decision variable. The second one is called as objective function. The second one is called as objective function. The third one is called as constraints. Constraints. And the fourth one is called as non-negative restrictions. Non-negative restrictions. Okay, or we also call it as NNR. So these are the 4 important steps that we have, which are supposed to be followed as far as linear programming is concerned. So all linear programming problem shall have these 4 important steps. So decision variable, then we have objective function, then number 3 comes constraints, and number 4 it is called as non-negative restrictions. Okay, so the way we come out with these 4 steps again depends on which question we are trying to address. So all linear programming problems are not alike. We have linear programming problem on marketing perspective. We have linear programming problem in financial perspective, production perspective, or general linear programming problems. So there are different types of problems we have. So depending on the complexity of the data involved in that particular question, this method also slightly varies. Andre ella questions tumba simple ah convert madlikagalla. Certain questions require some modification or some extra steps. I think that part you understand better when we take up the problems. Okay, so before I start with explaining the actual aspects of what exactly the decision, objective, and all that, I just want to ask the class, any doubts at this stage? Any questions you have in your mind, or it's all clear? Hello, any questions, any doubts?
No, sir.
No, sir.
I think you'll be able to understand the meaning of decision variable, objective function, constraint with an example, instead of just telling you theory, what exactly the meaning or definitions of it, which I'm sure you'll not be able to appreciate. I'll take a numerical problem or maybe a linear programming problem and then explain all these concepts. I think that will be better. Okay, which I'll take up in the next class. Yeah. So before we end the class for the day, I just wanted to brief you on the various methods that comes in linear programming problem, and then I think we can call it a day. Okay. So linear programming problem, as I already said, it is actually solved at 2 levels or 2 stages. The first stage is formulation. Now what is formulation? Converting a statement problem into these 4 methods: decision variable, objective function, constraint, and non-negative restriction. If 4 levels ke convert madidre, that is the first stage, and we call it a formulation stage. Adana formulation stage in kariti. Okay. Example in India, 2 types of questions can be asked. The first type is, they may simply ask you to formulate the problem. ಅಂದ್ರೆ ನೀವೇನು ಎಕ್ಸ್ಟ್ರಾ ಮಾಡೋ ಅವಶ್ಯಕತೆ ಇಲ್ಲ. ಆ ಸ್ಟೇಟ್ಮೆಂಟ್ ಪ್ರಾಬ್ಲಮ್ ಅಥವಾ ಸ್ಟೇಟ್ಮೆಂಟ್ ಅನ್ನ ನೀವು ಈಕ್ವೇಷನ್ಸ್ ಆಗಿ ಕನ್ವರ್ಟ್ ಮಾಡಬೇಕು. ದಟ್ಸ್ ಆಲ್. Just convert them into equation that completes the question. That means formulation. Formulation ಅಂದ್ರೆ ಏನು? You are forming the equations. That's all. The second stage ಏನಾಗುತ್ತೆ, once the equations are formulated or once the linear program is formulated, then you are supposed to solve that. So solving a linear programming problem is the second stage. Okay. Now, as far as linear programming problem is concerned, a linear programming problem can be solved by different methods. Bare methods. Nimma syllabus alli, we are going to deal with 2 important methods which are used for solving LPP problems. The first method is called as graphical method, and the second method is called as simplex method. Adre practically, if you look at, there are many other methods also. Nimge goal programming barutte, dynamic programming barutte, adadmele we have a sensitivity analysis. There are different methods available. A4 methods anta barutte, amele MU method anta barutte. There are different approaches actually, but as far as your syllabus is concerned, we are going to deal with only 2 methods. The first is called as graphical method, and second one is called as simplex method. So these are the 2 methods which are employed for solving a linear programming problem. And the last variety of questions that we have in this particular chapter is the problems on duality. Duality is the brother. What is duality? Every linear programming problem has got two phases. There are two phases there. The first phase is called as primal phase. The second phase is called as dual phase. Primal andre something which is just converted. And then if statement problem in the equations baritiralla, that simple equations are called as primal form. And duality andre the transpose of primal is called as duality. A matrix we talk about transpose of a matrix. And then rows are converted to columns or columns are converted to rows. The same principle is applied here also. The equations can transpose bardra. If you are able to write the mirror image of an equation, then that is called as duality. That is one concept we have. Of course, we are not having any problems or any questions on solving a dual problem, but the syllabus says you are supposed to convert a primal problem into dual problem. Very conversion matra irutte. Aga it's a very simple method. I think within 1 or 2 minutes you can solve that. But major things illi ಏನಂದ್ರೆ ಮೂರು aspects ಬರುತ್ತೆ. ಒಂದು how to formulate LPP. Number 2, how do we solve LPP by graphical method? And number 3, how do we solve the problem by simplex method? These are the three important part or important contents of this module. And of course, duality is also part of it, but it's a very, very relatively simple concept compared to the previous. Okay, so this is the overall content or overall things that we are going to study as far as the last module is concerned. I mean, from the syllabus point of view, it is third module, but from our completion point of view, it's a last module. Okay, so is it clear now? You got a fair idea about what exactly this chapter is all about, everyone?
Yes, sir.
Okay.
Yes,
I think with this background, we will start solving the numerical problems from next class onwards. I'll be sharing the complete theory notes of this module, like previous modules what I've done. And one more thing is, usually the linear programming problem questions are very lengthy. Each question will go on almost like half page or sometimes 2-3 paragraph. So I think it will be very difficult for me to dictate the question and then solve the problem. I'll be sharing questions too in the WhatsApp group like previous case, and you can have the questions with you so that we can straight away start solving the problem, so that it will save our time also, and you also have a question with you so that you can relate the question as well as answer. Is it okay with all of you?
Yes, sir.
Yes, sir.
I think now I think for this week it will be exactly as per the timetable, the regular timetable what we are following, because I think you have your EDP sessions between 4 to 5, right? 4 to 5 or 4 to 6, isn't it?
Yes, sir.
Yeah. Till how long these sessions are going on? Is it only for this week or even next week it goes on?
They have mentioned till 25th, sir.
Okay, no problem then. I think this week I'll completely take classes as per the timetable. Whatever sessions are there, anyway, I'm completed with other work also. And I think from Monday they are going to come out with a new timetable. And positively, I'll try to complete syllabus by max to max by next week or within next another 10 days maximum, so that you can probably take up the test of the last 2 modules, and we can complete the all formalities. Okay. If I remember, I think I am supposed to send the questions for a replacement problem, right? Replacement chapter. I have not sent any assignment questions, isn't it?
yes, sir.
Anyway, I'll be posting the questions by today or tomorrow. You can take some time. Maybe by next week end, you can complete that questions and you can send it across. And please make sure that you submit all the assignments without fail, because now during these difficult times, I think all these activities are very important. And because we want document for awarding marks, that's very important, because the university will definitely ask us for our documents for anything that is being given, because now this becomes very critical component now. ಹಾಗಾಗಿ ಎಲ್ಲರೂ ಅಸೈನ್ಮೆಂಟ್ಸ್ ಎಲ್ಲ ಸಬ್ಮಿಟ್ ಮಾಡಿ ಆನ್ ಟೈಮ್ ಅಲ್ಲಿ, ನಾಟ್ ಓನ್ಲಿ ಫಾರ್ ದಿಸ್ ಸಬ್ಜೆಕ್ಟ್, ಆಲ್ ಸಬ್ಜೆಕ್ಟ್ಸ್ ಐ ಆಮ್ ಟಾಕಿಂಗ್ ಅಬೌಟ್, because they all become the basis for internal assignments. That's why. Okay, yeah, I think we can stop the class for the day and I'll continue in the next class. Meanwhile, I'll try to send the questions of LPP so that we can directly solve the problem. Okay, so thank you all. I think we can continue the class in the next class. Okay, thank you.
Thank you, sir.